Okay, we are recording. So the first issue today, we're going to talk about how to find those solutions of previous quizzes, homework, or projects. It's actually very easy. It's just on the same page where the assignments are posted. You click on it. You find we have two quizzes already. The third quiz is coming today at the end of class. And we had one project. So if you click on the last quiz we did, now you see the solution is posted right under the quiz. So if you click on it, you can also download it. You see my written quiz. So please let me know if you notice any writing error in my solution. Okay. I think my solution is pretty clear already. However, I understand people may view it differently. Just let me know if you have any suggestions. That's where we can find those solutions. And the second point we're going to talk about today is complementary angle. Actually, when I was preparing for the teaching today about the exam one review, I found that one of important topic, which is not covered in our previous classes, is complementary angle. Okay. However, I don't think we have enough time to cover it today. It has appeared on the exam one review, and I think it will also appear on exam one next Tuesday. But we don't have enough time to cover it. Instead, so I just found a great short video about complementary angle theorem. Okay, so the theorem is pretty easy. It's not difficult. If you click on it, if the YouTube refuses to connect, you click on this button.
Okay, before we start doing examples with calculating trig functions and things like that.
So this is the 11 minutes video. It covers all the topics I want to say about complementary angle. Look, this is the theorem. Okay, just want to show 90 degree minus theta, sine of it, you get cosine. 90 degree minus theta, cosine of it, you get sine. That's it. It just helps you to switch from sine and cosine. Okay, for more explanation, please watch this video. This video is just 11 minutes. It's not now. When you watch it, if you have any difficulty, feel free to pause it. And most importantly, I'm here to help you. Tomorrow, Friday, I'm going to have office hour from 9:25 to 10:25. So if you watch this video, if you have any question about the complementary angle theorem, or if you have any question about the exam, which is coming next Tuesday, please let me know, okay? Please visit my office hour next tomorrow, Friday, okay? If you have any question, don't be shy. Okay, is that clear? So let's continue on our to-do list. Key points. Okay, we are going to have the third point today, phase shifts in graphs. So phase shifts in graphs is not difficult, okay? If you minus something, you are moving right. If you subtract something, you are moving left. Oh, sorry. If you add something, you are moving left. If you minus something, you are moving right. Just remember this sentence, okay? The class notes can be found here. Section 7.8 is here. I'm just going to click on it and let's work on it. Okay, let's see how this goes. As you can see, today's class notes is just one page. And as always, before we draw it on our hand, so let's first look at how it performs on the decimals, okay? Just to make things quick. Gradually, we're increasing the level of difficulty. As you can see, we have the sign, however, we have a number of times of it. And we are also have a number of times x and moving x by phi. Okay, this letter is Greek letter, it's called phi. Phi, okay. Philadelphia's phi, okay, phi. Plus b, and we're also shifting up or down by b units. Instead of drawing the picture of this directly, we factor the omega outside. Okay, we factor the omega outside so that we just have 1 times x inside minus phi over omega. Okay. And as the period begin when this thing starts from 0. Okay, I think this is pretty understandable. As you can, I hope you remember in our sine function, the sine function starts period from 0. Okay, so now, okay, so look at the function sine of sine. It starts from 0, it's go up and down, up. Then it's repeated itself again like this, starting from 0. Similarly, when we have a new function, y equal to sine, let's say, is pi x. Minus 1. Okay, this is a blue line. Can you tell me where the period starts? It looks very complex on the graph, right? It actually starts from x equal to 1 over pi. Okay. Look at this vertical line. Why it starts from here? Because if x equal to 1 over pi, this guy, what is this guy? You plug in x equal to 1 over pi. This guy is 0. Okay, this guy is 0. So it must, so this overall, this function turns out to be sine 0. Just like this sine x starts from 0, this is sine 0. So you can see it starts from here. This line, this green line, is a x over equal to 1 over pi. That's where its period starts. Okay, you see it's moving faster. It's fluctuating faster than the original sine x. But we know since x equal to 1 over pi here, then this part equal to 0 and the function starts this period. Okay, any question on this point? Why, if we create a new weird sine function with so many parameters, why it begins period from 0 when the inside formula is 0? Any question on this part? Okay, let me phrase it in the other way. The only thing matters is the overall performance of this part. If this part turns out to be 0, then it just behaves like sine 0. If this part turns out to be pi over 2, then this function is sine pi over 2. And this sine x starts from 0. So this part must also start from 0. And that's where 1x equal to 1 over pi is. Okay, this green line. It's green line. Okay. Any question before we continue? Okay. So let's first draw the class nodes functions on Desmos and to see how they behaves. Then we draw it by hand. So the first function we are going to draw today is y equal to 4 sine 2x minus pi. Let's see how that thing looks like. Y equal to sine, not sine x, sine 2x minus pi. Okay. Is that what we're drawing? Let's see. 4, I missed 4 in front. This function looks like this, okay? So this is a complex function. It has multiple parts. Let's see how it derives from y equal to sine x to this complex function. This is y equal to sine x, okay? Let's see how this function changes into this function. First, should we add 4 to the front, multiply 4 to the front, so that they share the same amplitude? Okay, now we see. They share the same maximum point and minimum point. Both of the minimum point are -4. Both of the maximum point is +4. Okay. Let's create a new function to make it more similar with our destination. This time we're not creating sine x. We're creating 2x. Okay. The graph looks messed up. We have so many pictures. So the black line is our previous drawing. The red line is here. Is a new function we're drawing. Now you see, once we did such a change, multiply with 2, the red line, which is a new function, oscillate or fluctuate more frequently than the black one. You see, the black one finished one period from here to here. However, the red line finished 2 periods from here to here. With the same distance, it finished 2 periods. Because we are multiplying with these 2, everything just accelerate. The fluctuation accelerated twice. That's why it's moving faster. It's shaking faster, okay? This is not our final destination yet. Okay, let's keep this red line, delete the black line. Okay, we still need to multiply with, minus with pi. So how do we do that? We just minus pi. Wow, I cannot find the purple line. Why so? This is simple, because once we minus pi, the red line covers the purple line. If we click on this button to get rid of the red line, you see the purple line. You see? The purple line is here. So we completely transform this original function into something we need, which is this one. On the class nodes, you were recommended to factor this thing out. If you factor 2 outside, so what's inside will turn out to be pi over 2 because you're factoring 2 out. So let's see what's the difference if we do not minus this pi over 2. Okay, the function looks like this red line. Okay, if we do not minus that pi over 2. If we minus that pi over 2, let's see how things are changing. Okay, pay attention to see where the origin is. Okay, to see where this peak is. Pay attention. The magic is performing. Oh, what happened? Where is our origin? You can say it's shifting right. Everything is shifting right by this pi over 2. Okay, because you're minusing that pi over 2, everything is shifting right. Everything is shifting right. So original origin is here. So you see, when you do this shift, still origin. However, remember the peak point. Okay, before we do the subtraction, the peak point is here, okay? This point is here. Then we do the subtraction. Pay attention to this peak point. Look, it's moved here. Okay, you see the difference? Peak point is here. Look, shift right by pi over 2. Okay, any question before we continue?
So Professor, so if in the parentheses, if it's x minus, it's shifting it to the right?
Yes.
And I'm assuming if you're adding it, it moves over to the left?
Very good. You completely get it. Thank you very much. Okay. So, does anybody else has any question before we continue drawing on them on paper? So let's do it on paper. I'm going to write the effect of every change step by step on the paper, okay? Switch to my document camera. Switching to my document camera. Stop sharing. Okay. So this is our lecture notes. I have written down some hints here already, okay? Previously, you have already saw this on decimals. When you times the A, feel the amplification. Originally, it oscillated like this. Now it's getting bigger and bigger. Feel the amplification. This just helps you memorize it. And when you times X, the X just oscillating faster. Assume this is a big number, okay? If this is a small number, everything slow down. And we also, when you are minus something, pay attention to our previous decimals. You feel this shift, feel, okay, the keyword is feel, help your memory, shift. If this is positive, you are shifting to the right. If you are add something, you are shifting to the left. Okay, I write everything down. A. Multiply the original amplitude by A. Okay, if A is a big number, it's getting bigger, the amplitude is getting bigger. If A is a small number, it's getting smaller, the amplitude. Look at my hand, how my hand is moving. Omega. Change the period to be 2 pi over omega. Okay, 2 pi over omega. If the omega is a number which is bigger than 1, for example, it's 2, as we just did. Now the new period is 2 pi over 2, which is just pi. Okay, so the smaller the period is, the faster it's moving, right? If you have a much longer period, it starts slowly going down, slowly. If you have a smaller omega, let's say you have 0.1, 2 pi over 0.1 is 2 pi times 10. The period is getting extremely slow, extremely slow. You're very hard to feel it. Okay, I'm just telling you how to memorize those coefficients. We don't have enough space here. So let me see where should I add this part, phi over omega. Okay, let's just add here, x minus phi over omega. Shift right the graph, phi over omega. This is your last step. Okay, shift right. If it is positive, okay, sometimes you x add phi over omega. This is positive. It means shift left, phi over omega. Let's just cross this out. I don't think we need this part. Okay, here assume this part is positive, okay? Minus a positive number, you are shifting right. Plus a positive number, you are shifting left. Okay, so that's the 3 components to transform the original graph into a new graph. Does anyone have any question? Let's continue. We have this function. We draw the picture already. So we know this function is 4 times sine 2x minus pi over 2. Okay, so the period, can anyone tell me what's the new amplitude? Just say it, please.
It'll be 4.
4.
Yes, great, it's 4. What's the new period? This is our omega, which is 2.
Wouldn't the new period just be pi?
Very good, okay? Omega changes the period to be 2 pi over omega. Omega is 2, so the new period is just 2 pi over 2, which is pi, which means the frequency of its oscillation is 2 times the original one, okay? Previously, it needs 2 pi to complete a complete period. Right now, since we are multiply with 2 to the x, feel this acceleration. We would only need pi to make 1 period, okay? It's getting faster. Feel this acceleration. Then shift. Can anyone tell me how this thing shift from the original graph?
To the right?
Very good. To right by how much?
Is it by 2?
Pi over 2.
Okay.
Great. To the right by pi over 2. Okay. Pay attention to what I write here. Minus a positive number shifted right by this thing. This thing, we can see it here. After we factor out is pi over 2. We have so much to do. So where does the period start? Okay, this is our last question before we draw the picture. Where does the period start? I'm pointing out a hint for you. Okay, well, this part is 0, right? If this part is 0, the whole thing inside the sign is 0. And we know sin x starts from period from 0. Okay, just that simple. So when would this part be 0? Anyone? Any brave person answer me?
Is it just pi over 2?
Very good. You get it. So when the pi x equal to pi over 2, this part is 0. So that's where it starts the period. Pi over 2 is here. It starts the period. Its amplitude is 4, so it's getting to 4. However, the new period is pi. Previously, it takes pi over 2 to get to pi. Sine pi over 2 is 1, where it reached maximum. Right now, you only take half of that period, which is pi over 4. Okay? Half of that pi over 2 to reach the maximum. So this is pi over 2. This is a pi. Pi, if you add a pi over 4 here, it should be somewhere here. So the maximum is at 10 somewhere here, and the maximum is 4, okay? Did we talk about shifting right by pi over 2? Yes, we actually talked about it already. Because when we were talking about where it starts from origin, we already shift from 0 to pi over 2 already. We already made this shift when we started from origin. Okay, so the shift has already been made. As 4 is here. Then it reach back to here. Because this one is pi, you get into pi. If you plug pi into it, you see this is sine 2 times pi over 2, which is sine pi, which gives you 0. Everything just shrinking by half. So if you add another pi, it reaches another pi over 2, okay, another pi over 2. You reach its minimum here. If you add another pi over 2, you get to this, which goes back to the 0. Okay. So let's make a nice graph of it. I said we make a nice graph of it. However, my graph does not look nice. Just bear with me. I'm a poor artist. Okay, we finished drawing one period. Okay, let me repeat. The period is pi. This point is pi over 2. So pi over 2 plus pi must goes back to itself, which is 3 pi over 2. So now you see it's getting to 0 here. Okay. Any question on this one? Add a mark 4. Add another mark -4. Okay. Need a bit nicer. Add a dashed line. Okay. Let's just continue. This is very similar with what we did. Instead, we just have cosine. Okay, the same principle applied. Number one, multiply the original magnitude by amplitude by a. Number two, change the period to be 2 pi over omega. Number three principle, shifting right or left, depends on whether you are minus or plus. Okay. Cosine x does not bother us. We treat it as same as sine x. If you do such a factorization, see what's inside, you get pi over 6. Okay, again, 2 times. So the amplitude is 2. Omega is 3, which means the period equal to 2 pi over 3. Shift, how does that essentiate? We are plus pi over 6, okay, plus. So shift to the left by pi over 6. Okay. Originally, the cosine x starts its maximum from here, right, at the origin. I hope you still remember. So if you don't remember, let me show you immediately. Let me show you. Look, this is our cosine x. It reaches maximum at the origin. So it starts everything from the origin to be the maximum. Then it decreases. Then to the bottom when approaching to pi, this point is pi. Okay. Then it's going up and reach the maximum again at 2 pi. Okay, so we have all the information we need. Amplitude is 2, period is 2 pi over 3, and shifting left by pi over 6. So originally it appears attains maximum here. Now you are shifting left by pi over 6. Pi over 6 is approximately 1/3 of pi over 2. So you approximately reach your maximum, first maximum here. And your maximum is your amplitude, which is 2. 2 approximately is here. Okay. Can you see? Oh yeah, I need to switch my screen to start everything.
I have a quick question.
Yes, please.
How did we get to pi over 6 when the original equation had pi over 2?
Very good question. Because we are factoring the omega out. Okay, omega here is 3. If you factor out 3 to put x with this guy together, you should also factor out 3 from here. So this guy should divide by 3. So that's why pi over 2 is converted into pi over 6. Okay, pay attention to the processes here. Hello, did I answer your question?
Yes, thank you.
Thank you for asking. Great, I really appreciate those people who ask me questions. Okay, so make sure you factor out this omega. Let's continue. It starts its maximum at this point, and we know the amplitude is 2, so which means the maximum is 2 and the minimum is -2. The period is 2 pi over 3. Okay, so this x coordinate is negative pi over 6 because we are shifting left by pi over 6. Okay, so it decrease then increase to complete one period. This point we know it is negative pi over 6. So when does it complete its period? Just add this period, right? Add 2 pi over 3. What do you get? So you get 4 pi over 6. 4 pi over 6 plus minus pi over 6 is 3 pi over 6, which gives you pi over 2. That's where it finished one period. So it goes back to its maximum here again. And the middle point is where it attains minimum. Or you can say it goes to its minimum if you add half of the period, okay? Just remember how the cosine looks like. Let me show you again on the graph. Okay. This is how cosine looks like. From here to here, it completes a complete period. However, it reaches minimum when it just completes its half period, okay? So we can do the same thing because everything is just compressed, but remains the same shape. We attain the minimum in the middle way between two periods. The middle way is, what's this middle point is coordinate. So it is negative pi over 6 plus half of the period plus pi over 3. Pi over 3 is 2 pi over 6, so you eventually get pi over 6. Pi over 6 is here. So it's approximately here. This is negative pi over 6, this is positive pi over 6. They're approximately similar positioned, okay? So let's put it here. Okay, so now you know what you should do. Continue going up. Again, my graph is ugly, but you know, it should look like this already. So let's verify it on the graph, on the decimals. Okay. It's a function. 3x plus pi over 2. Just look out from here, okay, to here. Are we right? Just for this part. Maybe I should add x. Negative pi over 6 smaller than x smaller than pi over 2. Okay, so that's where it is looks like from our drawing, from here to here. Okay, so compared to what we draw, we found they're not exactly the same because my handwriting is so ugly. But you see, the shape is the same already. Okay. Okay, any question before we continue? Okay. So for the third one, we don't have enough time to cover it because we also need to talk about the exam review. Instead, I think I'm going to post a video about it today. Okay, by the end of today, there will be a video about it, how to join this. Okay, so we have done those two, that's great. And the third video of it, about this one, will be posting the module of this week by the end of today. Okay, and tomorrow from 9:25 to 10:25, I'm going to host my office hour. Feel free to drop in to ask me any question. Okay, so let's look at the exam review. Oh, by the way, I have updated our web page to put this graph on it because I think this graph is super important and super nice. So I put it here, okay? And other information are below it. So let's go to the exam review part. This review is made by our lead instructor, and you see her name is here. This is her name, that's why her name is here. She teaches different times from our class, so all of this information still belong to her. Okay, this is not in our class. Our class is having the exam on Tuesday, okay? Do not treat this as the exam. This is just her information, not my information. You will have an in-class part and a take-home calculator part, which is due at the midnight of this next Tuesday, okay? Do not cheat. This is the basic rule of any exam. And please figure out how to share your whole screen, your whole desktop screen by next Tuesday, okay? Since next time when I'm proctoring, I need to see your whole screen. The first question is unit circle, fill in the blanks, which you can find on the canvas. All you need to do is look at those angles to see how it changes from 0, 30, 45, 60, all the way back to 360. Okay, just read that graph, memorize it. So there are so many questions on this review. Before I talk about any question, let me first ask you, do you have any particular question you want me to answer?
So then we're not gonna get a exam review prior to the exam?
The review is posted already.
Oh, okay. But then like in class, are we gonna cover everything? Like go over it or no?
We are actually doing it right now. So
Okay.
the review is posted, and I sent you guys an email about a review yesterday. Do you guys notice that? And I posted a review on Monday, so I sent you an email yesterday. So I hope you have looked at the review already. If you have not, don't worry. The answer key will be posted by midnight tomorrow. Right now, I'm just trying to answer if you guys have any question, if you have looked at it already. So does anyone has any question?
Wait, so what is this a study guide then?
Yes, the exam
Okay.
review is the official study guide for the coming exam.
Okay.
The coming exam will be very, very similar with this review.
What section or all section is exam, right?
The section is written down here. So all the important information should be written down somewhere. So it says section 7.1 to 7.5 and 9.1. That's it.
Okay, thank you.
For extra practice, if we went into the textbook and looked at 7.1 through 7.5, would we find like extra practice to do?
I would strongly recommend you guys review the examples did in our class and did in our textbook. I sent you guys an email yesterday. Do you guys see the email about the secret of quiz making?
Yes.
Okay, let me share the email again in case some of you didn't see my email. I sent you an email yesterday. It's in my inbox. So quiz. Okay, this email, the secret of quiz making and exam 1 is coming. I sent it yesterday on Wednesday. So the secret is that I'm adapting the class examples or textbook examples to make them the quiz questions. For the exam questions, they are also very similar. But the exam is not made by me. As I look at the exam, I think they are very similar, but they're a little bit more difficult. They go beyond the quiz level, okay? So quiz is supposed to be easy. Exam is a little bit harder, but they are the same type of questions you can find in the textbook and what we did in class. So if I see 45 degree in the textbook, I may change it to the 60 degree. If I see 60 degree, I may change it to a 30 degree, and so on and so on. I just make those adaptations. But the goal is help you to form a good habit that reviewing and complete understands books examples. If you do the review, you should feel confident. I do this intentionally so that you would pay attention to it. And if you do the review, you will do good on the quiz. If you do not review, you will not do good. It's just that simple, just that simple. Okay, and I also mentioned that please have a look at the exam 1 review. all the important dates can be found in syllabus, and all important files can be found in the module of Canvas. Okay. This is the important email I sent yesterday. So any question before we continue to talk about the review?
On the exam,
I'm sorry, can you speak louder?
how many question is the exam? You said section 7.1 through 7.5 and 9.1, right?
As for the form of the exam, it will be very, very similar with this review, okay? You should accept the same amount of questions found in a review and the same amount of questions found on the actual exam.
Okay, thank you.
Okay, cool, thank you for asking. Any question?
Professor,
Yes.
could you go over question 1F?
Okay, thank you. So let me switch to my document camera. Let's just use the reverse page. Okay, this is 1F, right? Do not overthink about it. Everything just use the basic definition and basic theorems. So what is cotangent x? By our definition, it's just cosine x over sine x. Do you agree?
Yeah.
Yeah, great. Then you have fraction at 1. So convert them into the same thing. Okay, this is 1 is just sine squared over sine squared. If you convert them into the same thing, you have sine squared in the bottom. Do you agree with this step?
Yeah.
So then by the Pythagorean theorem, once they added it, you got a 1. Do you agree?
Yeah, that makes sense.
Okay, then you got, this is just cosecant squared theta. That's it.
Okay. Yeah, thank you so much.
Thank you for asking. Anyone else has any question about the review? About anything about this class?
Could you show that example one more time?
My pleasure. Do you see the screen?
Yeah, thank you.
Thank you for asking. Okay, so it is very funny to say that. Oh yeah, someone asked me a question in the chat session. Okay, unfortunately, there will be no opportunities for retesting. Okay, so what you did on the exam on next Tuesday will be your score. There's no retesting. Okay, so be prepared for next Tuesday. And the best way to prepare them is review your books and your class examples and do this review. The solution set will be posted by the end of tomorrow. Okay, so that you have the whole weekend to look at the solutions. But before you look at the solutions, please try to do it on your own. I know many of you don't have questions because let's just face the fact, you have not started working on this review yet, right? Just tell me the truth. Don't worry. So tomorrow, again, let me repeat, 9:25 to 10:25 is my office hour. You can just drop in to ask me questions, just like we did in class, okay? And the answer key will be posted by end of tomorrow. That's it.
Do you have any other office hours before the test?
Okay. So let me think about it. I'm considering to add another office hour next Sunday or Monday. I'm thinking about it. I'm not decided the timing. So I'm trying to find a time which is good for as many possible and as many people as possible. Okay, so thank you for asking me that. One more additional office hour will be hosted on next Sunday, which is 3 days later, or next Monday, which is 4 days later. Thank you for asking. Does anyone else has any question? Okay, cool. So it's very quiet. We cannot continue on this review because most of you have not tried it yet. But don't worry, we have something else to do. Look at the assignment. We have our third quiz coming in a few minutes. Okay, so you can kind of get yourself prepared for the third quiz, which covers last week's sections. That's it. And share your screen. Share all of your desktop screen. Not just your web browser. Share all of your desktop. Okay, get ready for the new quiz. Share your complete screen, okay? Not just your web browser. Look what I did. This is my complete screen, okay? You can see my desktop. You can see all the
It
files.
says that the host disabled participant screen sharing so far.
Thank you for reminding me that. Let me change that. Stop sharing. Okay, now you can. Share all of your desktop. Wow, someone has a PayPal. I'm just joking. Never mind. Okay, everybody share your screen and get ready for the quiz. Quiz can be downloaded at 9 a.m. Make sure you scan it as a PDF.
Do we have until 9:35 to complete it?
Yes.
Okay, thank you.
I think the quiz can be done in 15 minutes. However, I know many of you are still facing technical difficulties. So I give you 20 minutes extra so that you can scan it as uploaded as PDF. Those routine procedures, once you've done it several times, I think you can finish it in 1 minute. Okay, 1 or 2 minutes. So just to be generous, I give you 20 more minutes so that you will feel confident. Okay, everybody share your screen. Share your complete screen, including your desktop. Okay, the quiz is available, so start working on it. Do not overthink about anything. Everything appears on the quiz should be very simple, very similar with what we did in class. There's no advanced stuff there. Everything can be written down in 1 or 2 steps. If you have too many steps, I'm very confident to tell you that you might be wrong, in the wrong direction. Everything should be simple. Start working on a quiz. Start work on your quiz. Everything should be simple. Do not overthink about anything.